June 15, 1942. Imperial Japanese Navy Headquarters, Tokyo, Japan. Commander Minoru Genda straightened the intelligence report on the mahogany table, his fingers smoothing the paper with practiced dismissal. "Look at this," Genda said, tapping the document with his knuckle. "The Americans claim they can replace Yorktown within months. They cannot even build proper roads." Captain Toshikazu Omi leaned forward, nodding with agreement. "Their industrial workers strike for higher wages while our people sacrifice everything for the emperor." Lieutenant Commander Yahachi Tanabe, Intelligence Section Chief, shifted uncomfortably in his chair. "Commander, the American shipyard capacity measurements show concerning expansion rates at Newport News and Philadelphia." But Genda waved him off. "We have sunk 4 of their carriers at Coral Sea and Midway. They possess 6 total. We still command 8 fleet carriers with superior aircraft and experienced pilots." At Pearl Harbor, the kill ratio was 8 battleships to 0 Japanese losses. At Coral Sea, Lexington sank while Shikaku merely withdrew for repairs. At Midway, they lost Yorktown while Japan sacrificed 4 carriers but retained superior pilot quality. The mathematics were undeniable. Japan's naval aviation dominance remained absolute. What Genda didn't know, what none of them could have known as they reviewed intelligence summaries in that headquarters building, was that American Shipyard Innovations would launch 24 fleet and light carriers within 36 months. The numbers would become grotesque: 24, 2, 141,000 aircraft to 76,000, 4 million tons of warship construction versus 600,000 tons. The confident dismissal in that Tokyo headquarters would become history's most expensive miscalculation, measured in 2.1 million Japanese military deaths. Commander Genda had earned his contempt through victory. He planned the Pearl Harbor attack that achieved tactical perfection. 8 American battleships destroyed or damaged in 110 minutes. 2,403 Americans killed. Japanese losses: 29 aircraft, 5 midget submarines, 64 men. The kill ratio was 2,403-64 or 37, 5-1 in personnel. At the Battle of Ceylon in April 1942, his air group sank the British carrier Hermes in 10 minutes. Elapsed time from first bomb to sinking, 600 seconds. 22 bombs struck Hermes. Kill time per bomb run, 27 seconds average. The carrier sank with 307 crew. Additional kills at Ceylon: heavy cruisers Cornwall and Dorsetshire, destroyer Vampire, 23 merchant vessels. Total enemy tonnage sunk, 114,000 tons. Japanese losses: 17 aircraft. His combat record showed 17 successful operations across 14 months, 0 tactical defeats. Vice Admiral Chuichi Nagumo personally praised Genda's tactical planning in official dispatches. Captain Omi commanded destroyer divisions that never lost an engagement in 1941. His ships sank Dutch destroyer Kortenair off Java with a single torpedo salvo. Kill time: 90 seconds from launch to explosion. Elapsed time from sighting to sinking: 240 seconds total. At the Battle of Sunda Strait, his destroyers sank heavy cruiser Houston and light cruiser Perth with 0 damage sustained. American torpedoes malfunctioned. American aircraft burned easily when struck. American ships lacked adequate anti-aircraft protection. He witnessed 14 separate engagements proving Japanese naval superiority. The American industrial reputation meant little against Japanese night-fighting superiority and torpedo expertise that sank enemy vessels faster than they could respond. Lieutenant Commander Tanabe presented capacity analysis from intelligence operatives in neutral Switzerland. "Sir, American aluminum production currently exceeds 400,000 tons annually. Our intelligence suggests expansion to 920,000 tons by 1943. The Aluminum Company of America operates facilities in Tennessee, North Carolina, and Washington State. Single American facilities are producing more monthly tonnage than our entire national output." Genda examined the figures with visible irritation. "These numbers reflect peacetime luxury production for consumer automobiles and kitchen appliances. War requires discipline and sacrifice, qualities Americans lack. Their workers demand 8-hour days. Our people work 12 hours without complaint. Their union leadership threatens strikes. Our workers volunteer for extra shifts." Tanabe continued with statistical documentation. Newport News shipbuilding reports suggest construction acceleration beyond normal shipyard capabilities. They claim assembly methods using prefabricated sections that reduce carrier construction from 36 months to 14 months. The intelligence includes photographic evidence of modular construction techniques. Omi laughed with genuine amusement. propaganda designed to inflate their capabilities and demoralize our forces. Quality naval construction cannot be rushed. Carriers require precision engineering power plants, armor placement, aviation facilities, damage control systems. Speed without quality produces floating coffins. American carriers are already inferior in design, thin armor plating, inadequate torpedo protection systems, poor compartmentalization for damage control. Rushing construction will only magnify their engineering deficiencies. Seaman Hiroshi Nakamura served aboard Shikaku during the Coral Sea engagement in May 1942. He witnessed American carrier Lexington burning after torpedo strikes delivered by Japanese aircraft at 11:20 hours. American damage control teams fought the fires and flooding for 7 hours before abandoning ship at 17:07 hours. Elapsed time from torpedo impact to abandonment, 347 minutes. Japanese carriers sustained damage at Coral Sea, but remained operational through superior compartmentalization design and crew training in damage control procedures. Shikaku took 3 bomb hits. Damage control teams sealed breached compartments, extinguished fires, and restored partial operations within 90 minutes. The carrier withdrew from battle but steamed under its own power back to Japan for repairs. At midway on June 4, Nakamura watched from Huryu as American torpedo bombers approached at wavetop height in 3 separate attacks. Japanese Zero fighters intercepted the first squadron of 15 aircraft, all 15 Devastators destroyed. Kill ratio, 15-0, elapsed time 6 minutes. Kill time per aircraft, 24 seconds average. Second squadron, 13 aircraft, all 13 destroyed. Kill ratio, 13-0, elapsed time 5 minutes. Kill time per aircraft, 23 seconds average. Third squadron, 10 aircraft, all 10 destroyed. Kill ratio, 10-0, elapsed time 4 minutes. Kill time per aircraft, 24 seconds average. Total American torpedo bomber losses, 41 aircraft, 41 aircrew. Japanese losses, 0 aircraft, 0 casualties. Not one American torpedo struck a Japanese carrier during these attacks. American aircraft were obsolete in performance. American tactics were suicidal in execution. American training was inadequate for Pacific combat operations. American industrial capacity meant nothing when aircraft burned before reaching targets. Japanese naval aviation represented the pinnacle of military development achieved through 20 years of focused training and combat experience. Nakamura's personal experience confirmed what leadership declared. American industrial capacity could not overcome Japanese combat superiority demonstrated in 17 consecutive victories. The mathematics seemed irrefutable. Norfolk, Virginia, March 1942. Henry J. Kaiser studied the empty dry dock at Norfolk Naval Shipyard. This single facility would produce 14 escort carriers using prefabrication methods that transformed maritime construction from craft to mass production. Every 7 weeks, another carrier hull would slide into the water. Traditional shipbuilding required laying keel in dry dock, building frame structure vertically, installing machinery sequentially, constructing superstructure piece by piece, outfitting interior compartments individually over 36 months of sequential labor. Kaiser's revolutionary approach fabricated entire bow sections, stern sections, midship sections, engine room modules, and island superstructures simultaneously in assembly buildings covering 40 acres, then welded them together in the dry dock in 14 months using electric arc welding instead of riveting. In January 1942, America produced 0 escort carriers monthly. By April 1942, production reached 1 carrier every 60 days at Kaiser facilities. By November 1942, Newport News Shipbuilding was producing 1 Essex-class fleet carrier every 4 months, while Kaiser yards launched Casablanca-class escort carriers every 49 days. By February 1943, combined American shipyard production reached 3.2 carriers monthly, including fleet carriers, light carriers, and escort carriers. This single coordinated facility network was producing more carriers monthly than the entire Japanese Empire, constructed annually through its entire naval shipbuilding industrial base, including Kure, Yokosuka, Sasebo, and Nagasaki arsenals combined. Margaret Whitfield, previously a department store sales clerk from Richmond, Virginia, now operated a massive overhead gantry crane moving 60-ton propeller shaft assemblies from machining shops into carrier engine rooms. Every 8-hour shift, Her crane moved 24 major components weighing between 40 and 180 tons into hull compartments with positioning precision measured in inches. She lowered diesel engines weighing 180 tons into engine room spaces using cable systems she learned to operate in 14 days of training. She positioned reduction gears weighing 90 tons onto mounting beds with alignment tolerances of 1/8 inch. She moved electrical generators weighing 75 tons into compartments barely larger than the equipment itself. In one 8-hour shift, she moved 1,840 tons of major equipment using crane systems worth $340,000. The entire Japanese Kure naval arsenal moved 1,200 tons of major components daily using 42 cranes operated by workers with 3 years of apprenticeship training. Margaret alone handled more tonnage in one shift than 5 Japanese workers handled in one day, using equipment that cost more than Japanese yearly crane budgets, after receiving training that lasted 1/40th as long as Japanese apprenticeship requirements. Her workstation represented one position among 30,000 workers at the facility. Japanese carrier production at Kure employed 8,000 workers total. The ratio was 3:75:1. American facilities employed nearly 4 times as many workers per construction project, because abundance permitted massive labor deployment while Japanese scarcity forced careful resource allocation. Margaret received $1.20 per hour, $9.60 per day, $57.60 per week. Japanese shipyard workers received 4.8 yen daily, equivalent to $1.10 per day at official exchange rates, $7.70 per week. American workers earned 7.5 times Japanese wages while producing 3.4 times more output per worker. The productivity advantage exceeded wage advantage. American industrial methods created efficiency that compensated for higher labor costs through engineering precision that eliminated skill requirements. James Washington, from Atlanta, Georgia, operated electric arc welding equipment that joined steel plates forming carrier flight decks with continuous weld beads that created structural integrity impossible with traditional riveting. His welding guns operated at 440 amperes of electrical current, joining 1-inch steel plate at 36 linear inches per minute with penetration depth of 3/4 inch, creating welds stronger than the base metal. Every 8-hour shift, Washington welded 480 linear feet of flight deck plate joints, moved between work positions 12 times, changed electrode rods 48 times, and inspected his completed welds using magnetic particle detection methods. His single workstation's daily output exceeded the entire weekly welding production at Yokosuka Naval Arsenal, measured in linear feet of structural welds completed. Japanese welders used oxyacetylene torches requiring manual skill developed over years of practice controlling flame temperature, torch angle, and filler rod feeding rate. Washington received 21 days of training on electric arc welding equipment that automatically regulated current, maintained constant arc length, and fed electrode wire at mechanically controlled rates that eliminated manual skill variation. The welding equipment cost $8,900 per unit. One machine replaced 12 traditional oxyacetylene welding stations in productivity. Washington operated 6 welding machines during his shift, moving between them as material handlers positioned new plate sections. His personal productivity exceeded 72 Japanese welders working identical 8-hour shifts using traditional welding methods. The productivity ratio was 72:1 per worker. The cost ratio was less favorable, $53,400 in equipment for Washington's 6 machines versus $3,600 for 72 Japanese torch sets, but the speed advantage compensated. Washington completed in 8 hours what Japanese teams completed in 6 weeks. When time determines military advantage, equipment cost becomes irrelevant compared to production velocity. Robert Chen, from San Francisco, California, operated precision milling machines that fabricated aircraft catapult components requiring tolerances of 1/1000th of an inch across steel parts weighing up to 800 pounds. His machine shop station produced 16 catapult piston assemblies per week, each requiring 47 separate machining operations across 8 different specialized milling machines. Chen learned to read engineering blueprints in 6 days, operate precision measuring instruments in 4 days, and set up complex machining sequences in 11 days. Total training, 21 days. Japanese machinists underwent 4-year apprenticeships before operating similar equipment. Chen's weekly output of 16 assemblies exceeded the monthly output of 6 Japanese machinists at Sasebo Naval Arsenal, who produced 9 assemblies monthly using manual machine operation methods. American automated milling machines performed repetitive operations at mechanical consistency impossible for human operators. Chen set cutting speeds, feed rates, and depth parameters once per day. Machines executed operations identically for 8 hours. Japanese machinists manually controlled every cut, adjusted every setting, and measured every dimension continuously. The human variation created dimensional inconsistencies, requiring extensive hand fitting during assembly. American parts bolted together without modification because mechanical consistency eliminated fitting requirements. The time advantage was catastrophic. American carriers required 1,200 fewer man-hours during final assembly because prefabricated components fit precisely without adjustment. This single efficiency, parts compatibility, reduced construction time by 18 days per carrier. Across 12 carriers under simultaneous construction in 1943, this single efficiency advantage saved 216 days of construction time, equivalent to completing an additional carrier every 7 months from time savings alone. William S. Knudsen, $1-a-year man from General Motors, managed production scheduling across 12 shipyards and 640 supplier factories that delivered 1,847 standardized components for Essex-class fleet carrier construction. He implemented automotive assembly techniques in shipbuilding, standardized components manufactured to interchangeable specifications, modular construction with complete subsystems fabricated separately, parallel production streams eliminating sequential bottlenecks, and just-in-time delivery coordinating supplier production with assembly requirements. Traditional shipbuilding treated each vessel as a unique creation. Master shipwrights designed solutions for individual problems. Workers adapted techniques for specific situations. Each carrier was subtly different. Shikaku and Zuikaku, sister ships built from identical plans, had 340 non-interchangeable components requiring separate manufacturing processes and distinct spare parts inventories. Knudsen's system produced carriers like automobiles, identical specifications across all hulls, mass-produced components with interchangeable dimensions, assembly line integration where any part fit any position in any ship. Essex-class carriers used 1,847 standardized components. Each component was manufactured by between 3 and 7 suppliers to prevent production bottlenecks. If Bethlehem Steel's turbine production encountered delays, General Electric's turbines installed without modification. If Westinghouse electrical panels had quality issues, Allis-Chalmers panels replaced them instantly. Japanese carriers were custom-designed with components manufactured by single suppliers. If Kawasaki delayed turbine delivery, construction stopped until Kawasaki resolved problems. No alternative supplier existed. No backup production capacity existed. American redundancy eliminated delays. Japanese single sourcing created vulnerability. Americans discarded 2,400 tons of steel plate trimmings daily from carrier construction across all active shipyards including Newport News, Philadelphia, Brooklyn, Norfolk, Mare Island, and Bethlehem Fall River. Japan allocated 1,800 tons of steel monthly for entire naval aviation programs including aircraft manufacturing, carrier construction, air base facilities, and shore installations. The waste from single-shift operations at 6 American shipyards exceeded enemy monthly steel allocation by 33%. Workers threw away steel offcuts measuring 6 inches by 12 inches that Japanese shipyards carefully collected, stored, melted in electric furnaces, recast into plate, and reused in construction. American abundance made waste economical. Transporting scrap steel to recycling facilities cost $14 per ton. New steel plate cost $38 per ton. The difference was $24 per ton. Loading, transporting, unloading, sorting, and melting scrap required 12 man-hours of labor. At $1.20 per hour, labor cost $14.40. Total scrap recycling cost, $28.40 per ton versus $38 per ton for new steel. The savings was $9.60 per ton, or 25%. But time cost exceeded money savings. Recycling required 6 weeks. New steel arrived in 4 days. When construction schedules demanded completion, time value exceeded cost savings. American decision-making prioritized speed. Japanese decision-making prioritized conservation. Speed won. Conservation lost. The mathematics proved that when production velocity determines strategic advantage, waste becomes strategy and conservation becomes liability. The cafeteria at Newport News Shipbuilding discarded 18,000 pounds of food daily from breakfast, lunch, and dinner service for 30,000 workers consuming 3 meals during round-the-clock shift operations. Yokosuka Naval Arsenal workers received 14,000 pounds of food weekly for 8,000 personnel working single-shift days. Daily rations, 2,000 pounds for 8,000 workers. American shipyard workers threw away 9 times more food daily than Japanese construction and combat sailors received daily for consumption. The discarded food included 2,400 pounds of bread, rejected because it was baked yesterday instead of today. 3,100 pounds of meat trimming and fat cut away before cooking. 4,200 pounds of vegetable peelings and spoiled produce. 2,800 pounds of dairy products approaching expiration dates. 5,500 pounds of prepared food that workers did not select from cafeteria lines. Japanese workers received 1,200 pounds of rice daily, 420 pounds of fish daily, 280 pounds of vegetables daily, 100 pounds of miscellaneous provisions daily. Total, 2,000 pounds. American waste exceeded Japanese provision by 800%. American workers consumed more calories daily than Japanese military personnel in active combat zones. Nutritional analysis. American shipyard worker diet, 4,200 calories daily with unlimited access to beef, pork, chicken, milk, cheese, bread, potatoes, and vegetables. Japanese sailor diet, 2,800 calories daily with rice, fish, limited vegetables, and occasional meat. American workers ate 50% more calories than Japanese combat forces. The caloric advantage directly determined productivity. Well-fed workers operated machinery 12 hours daily without fatigue. Underfed workers lost strength and focus after 8 hours. The productivity difference wasn't cultural or ideological, it was biological. Human bodies require fuel for sustained labor. American abundance provided unlimited fuel. Japanese scarcity enforced rationing. Biology favored abundance. Americans threw away aluminum shavings from machining operations that Japan rationed by the gram to aircraft manufacturers desperate for any metal to fabricate airframes. Machine shops at carrier construction facilities generated 840 pounds of aluminum turnings and chips daily from milling operations that shaped aluminum components for aircraft catapults, arresting gear mechanisms, and structural brackets. Japanese aluminum allocation for aircraft manufacturing across all contractors, Mitsubishi, Nakajima, Kawasaki, HI, totaled 1,800 pounds monthly for entire fighter production programs. American single-day machining waste from single facility exceeded Japanese monthly allocation for all combat aircraft production by 28 days' worth of Japanese budget consumed in American waste bins in 24 hours. Workers swept aluminum chips into trash drums without thought. Japanese manufacturers weighted out aluminum fragments on precision scales and recorded every gram in inventory logs. American machinists ordered new aluminum bar stock when current stock measured less than 12 inches remaining. Japanese machinists used aluminum pieces down to 1-inch remnants welded together to form usable stock. The waste represented philosophical differences. American industry optimized for labor efficiency. Moving aluminum to recycling cost more than buying new aluminum. Japanese industry optimized for material conservation. Aluminum imports were impossible. Every gram required conservation. American philosophy won because Pacific War rewards production velocity, not resource management. You cannot conserve your way to industrial victory when opponents produce faster than you can save. Discarded ammunition in testing protocols exceeded Japanese combat allocation across entire Pacific Theater monthly expenditure rates. Ammunition test facilities at Aberdeen Proving Ground and Dahlgren Naval Proving Ground fired 340,000 rounds monthly testing new weapons, evaluating improvements, conducting acceptance trials, and training inspectors to identify defective ammunition. Japanese monthly rifle and machine gun ammunition allocation for Pacific garrisons across Rabaul, Truk, Kwajalein, Saipan, Guam, Palau, and Philippines combined, 280,000 rounds. American testing alone consumed 21% more ammunition than enemy combat operations across the largest military theater in human history. The ammunition fired in testing was deliberately destroyed. Weapons were fired to failure to determine mechanical limits. Ammunition was exposed to temperature extremes, humidity, saltwater immersion, and impact stress, then fired to identify degradation. Inspectors fired thousands of rounds daily checking quality. Japanese forces rationed ammunition at 10 rounds per rifle per month for garrison troops. American test facilities fired 11,000 rounds daily through single rifles until the barrels burned out to measure barrel life. One American test rifle consumed more ammunition in 3 days than 110 Japanese soldiers received monthly. The expenditure demonstrated economic absurdity that defined American advantage. Waste more testing than enemies spend fighting because production exceeds any consumption rate. When factories produce unlimited quantities, consumption limits disappear. Industrial abundance eliminates resource constraints that determined all previous warfare. Norfolk Naval Shipyard's daily electrical power consumption exceeded the entire city of Hiroshima's monthly power budget. The shipyard operated 72 massive electric arc furnaces, 440 overhead cranes, 1,200 electric welding stations, 890 precision milling machines, and 14,000 electric lights continuously across 3 shifts. Daily power consumption, 2.4 million kilowatt-hours. Hiroshima monthly power allocation for 340,000 civilian residents plus military facilities, 1.8 million kilowatt-hours. Single American shipyard consumed 33% more electricity daily than an entire Japanese city consumed monthly. The power waste from lighting empty buildings and pathways overnight exceeded Japanese naval base power allocations. Overnight lighting for safety and security, 180,000 kilowatt-hours. Japanese naval base at Kure monthly allocation, 140,000 kilowatt-hours. American safety lighting exceeded Japanese operational power. The electrical consumption represented strategic advantage. American power generation capacity exceeded any consumption requirement. Japanese power generation struggled to meet minimal requirements. American shipyards operated without power constraints. Japanese arsenals carefully scheduled power-intensive operations to avoid overwhelming electrical grids. Industrial capacity requires power. Power requires generation infrastructure. Infrastructure requires coal, hydroelectric dams, and transmission lines. America possessed unlimited power. Japan rationed electricity for military production. The strategic advantage originated in infrastructure built decades before war began. Industrial mobilization depended on electrical capacity installed during peacetime economic development. Nations cannot build power infrastructure during wartime. They use capacity constructed previously. American abundance reflected 50 years of industrial expansion. Japanese limitations reflected insufficient infrastructure development. Lieutenant Commander Tanabe received production reports from intelligence operatives in neutral Portugal who monitored American industrial publications, War Production Board announcements, and corporate shareholder reports that American law required companies to publish quarterly. American shipyard employment December 1941, 478,000 workers. Shipyard employment June 1942, 894,000 workers, an 87% increase in 6 months. Projected employment December 1942, 1.2 million workers, a 151% increase from pre-war levels in 12 months. He calculated construction capacity using conservative assumptions. If American claims of 14-month fleet carrier construction were accurate, and if 6 shipyards were simultaneously building fleet carriers using parallel production methods, the United States would launch 24 fleet carriers by mid-1944 from current construction starts. He added intelligence about escort carrier production. Kaiser facilities claimed 48 escort carriers by the same date using 7-month construction timelines. Combined total, 72 carriers of all types within 26 months from June 1942 baseline. He presented these figures to Commander Genda during morning briefing at headquarters. Sir, if these calculations are remotely accurate, American carrier strength will exceed 80 vessels by mid-1944. Our current operational strength is 8 fleet carriers following Midway losses. Maximum Japanese production capacity suggests we can construct 12 carriers by 1944, assuming no additional combat losses and perfect construction execution. The ratio will be 80, 12, or 6, 7, 1 American advantage in hulls. Measured in aircraft capacity, American advantage exceeds 7,200 aircraft to 1,080 aircraft, also 6, 7, 1. Measured in displacement tonnage, American advantage exceeds 1.8 million tons to 264,000 tons, a 6:8:1 ratio. Genda examined the numbers with visible irritation bordering on anger. Your mathematics assume American propaganda statements are factual intelligence. They cannot possibly be building carriers at these rates. No nation has ever constructed warships this rapidly in human history. The British required 24 months to build Illustrious. The Germans required 30 months for Graf Zeppelin, which they never completed. Our own Shikaku required 34 months. You are suggesting Americans can build equivalent carriers in 14 months. This defies engineering reality. You are being deceived by psychological warfare designed to make us believe their capacity exceeds actual production. Tanabe prepared additional documentation. Sir, I have photographic reconnaissance from our submarine I-19 showing Newport News facility. The photographs clearly show 3 separate carriers under simultaneous construction using assembly techniques we do not fully understand. The construction involves building entire sections in covered buildings, then moving completed sections to dry dock assembly. This is not traditional shipbuilding. This is industrial manufacturing applied to warships. Omi interrupted. Even if Americans somehow build carriers faster, which I doubt, they cannot build quality carriers quickly. Their carriers will have inadequate armor, poor damage control, weak anti-aircraft defense. Building fast means building poorly. We will sink their rushed carriers as easily as we sank Lexington and Yorktown. Tanabe continued despite the dismissive atmosphere. I must also report alarming pilot production figures. American pilot training capacity has expanded from 1,200 annual graduates in 1941 to projected 30,000 annual graduates by 1943. This is 25 times expansion in training capacity in 2 years. Their training uses mass production methods, standardized curriculum, abundant aircraft for training, unlimited fuel. Japanese pilot training produces 2,400 graduates annually and cannot expand further due to fuel limitations and aircraft shortages. Genda stood from the conference table, signaling the meeting's end. Your warnings are noted, Lieutenant Commander. However, intelligence analysis must consider source reliability. American corporations benefit from exaggerating production to boost stock prices. American government benefits from psychological warfare suggesting capabilities they do not possess. We will defeat American naval forces through superior tactics, superior training, and superior fighting spirit. Their industrial numbers are irrelevant when their carriers burn and their pilots die. What Genda failed to calculate was that superior fighting spirit cannot overcome 7:1 production ratios. Superior training for 2,400 pilots annually cannot overcome 30,000 opposing pilots trained annually. Superior tactics cannot compensate when you deploy 8 carriers against 40 carriers. The mathematics were absolute even if commanders refused to accept them. Industrial capacity determines military capacity when quantity advantages exceed quality differences. American carriers did not need to be 7 times better than Japanese carriers. They merely needed to be adequate, because 7 adequate carriers defeat 1 excellent carrier through overwhelming force concentration. Genda's tactical brilliance could not overcome strategic production disparities of this magnitude. No tactical genius in history ever overcame 7:1 numerical inferiority sustained across years of conflict. Excellence cannot defeat mass when mass achieves minimal competence thresholds. October 27, 1942, Santa Cruz Islands, 7:40 hours. Seaman Hiroshi Nakamura was manning the forward lookout station aboard fleet carrier Shikaku when radar operators detected incoming aircraft at 60 miles, bearing 120 degrees relative. He raised binoculars at 7:41 hours, scanning the horizon. At 7:43 hours plus 30 seconds, he counted 43 dive bombers approaching from 14,000 feet altitude with fighter escort. American aircraft markings clearly visible, white stars on dark blue backgrounds. At 7:47 hours plus 10 seconds, the first 1,000-pound bomb struck Shikaku's forward flight deck 30 feet from the bow. Elapsed time from first visual sighting to first bomb impact, 6 minutes 40 seconds. The explosion penetrated 3 decks, destroying crew quarters and forward storage compartments, killing 109 crew members instantly. Nakamura felt the ship shudder from the explosion's force transmitted through the steel structure. At 7:49 hours plus 45 seconds, a second bomb struck amidships, destroying the starboard aircraft elevator that lifted aircraft from hangar deck to flight deck. The elevator mechanism, 180 tons of steel and hydraulic equipment, was blown upward by the explosion, then crashed down into the hangar bay. At 7:51 hours plus 22 seconds, a third bomb hit near the island superstructure housing the bridge, operations center, and communication equipment. The blast killed Captain Jajima Takatsugu and 26 bridge personnel. Elapsed time from first to third impact, 4 minutes 12 seconds. At 7:53 hours plus 18 seconds, a fourth bomb struck the aft flight deck, creating a 40-foot hole that prevented aircraft operations. Kill time per bombing run, 24 to 38 seconds average from aircraft releasing bombs to impact. At 8:08 hours, 5 additional bombs struck sister carrier Zuikaku. At 8:12 hours, 3 bombs hit light carrier Zuiho, destroying the flight deck completely. At 8:19 hours, the American aircraft departed after expending their ordnance loads. Total engagement duration from initial radar contact to American aircraft departure, 39 minutes. Enemy losses: Shikaku severely damaged, requiring 6 months repair; Zuikaku moderately damaged, requiring 2 months repair; Zuiho flight deck destroyed, requiring 4 months reconstruction; destroyer Teruzuki sunk, 349 crew killed across all ships. American losses: carrier Hornet sunk by subsequent Japanese airstrikes, 74 aircraft, 266 personnel. The battle produced tactical American defeat; they lost a fleet carrier. But strategic analysis revealed disturbing patterns. Americans deployed 2 carriers, Enterprise and Hornet. Japanese deployed 4 carriers, Shikaku, Zuikaku, Zuiho, Junyeo. The Americans achieved 3-0 carrier damage ratio despite numerical inferiority of 2-4. Their aircraft penetrated Japanese combat air patrol defenses despite fighter opposition. Their bombs hit carriers despite anti-aircraft fire. Their pilots pressed attacks despite losses. The tactical defeat obscured strategic warning. American combat effectiveness was improving while Japanese was declining. The ammunition expended in this 39-minute engagement exceeded Rabaul Air Base's monthly allocation of 500-pound bombs. American aircraft dropped 284 bombs totaling 142 tons of ordnance. Japanese monthly bomb allocation for Rabaul's 120 aircraft stationed at the primary forward base, 89 tons. A single American carrier strike force expended 160% of Japanese monthly allocation in 39 minutes. The expenditure rate was unsustainable for Japan. The expenditure rate was routine for America. When one side can afford to expend 160% of enemy monthly allocation in single battles, and the other side carefully rations every bomb, the expenditure advantage determines outcomes regardless of tactical skill. Nakamura observed American aircraft construction quality during the Santa Cruz engagement, with professional interest born from 3 years' naval aviation experience. Douglas SBD Dauntless dive bombers absorbed 7.7 machine gun fire from 0 fighters and continued attacking with apparent disregard for damage. He watched one aircraft sustain 47 visible hits. He counted the holes in the wings and fuselage as it passed overhead at 400 feet altitude and successfully returned to its carrier after dropping bombs. Japanese Navy Type 99 carrier bomber was constructed with minimal armor to maximize range and bomb load. 0 fighters lacked armor plating entirely and used non-self-sealing fuel tanks to minimize weight. The design philosophy prioritized performance over protection because Japanese industrial capacity could not afford to lose pilots regardless of aircraft losses. American aircraft design philosophy inverted this calculation. Sacrifice performance for survivability because factories produced replacement aircraft faster than combat destroyed them. SBD Dauntless carried armor plating protecting the pilot and gunner 200 pounds of steel that Japanese designers would eliminate. The aircraft used self-sealing fuel tanks that automatically sealed bullet holes to prevent fuel loss and fire technology that added 60 pounds and reduced fuel capacity by 12%. American designers accepted performance penalties because pilot survival mattered more than aircraft speed or range. The philosophical difference reflected industrial capacity. Japan could not afford to lose pilots with 3 years training. America could afford armor protection because replacement aircraft arrived from factories daily. Nakamura watched one burning American bomber with the right engine completely destroyed continue its attack run despite obviously fatal damage. The pilot released his bomb load with professional precision before ditching the aircraft near an American destroyer that immediately launched rescue boats. The pilot was recovered within 8 minutes. American industrial abundance enabled tactical choices impossible for resource-constrained forces. Protect pilots because pilot training costs more than aircraft construction. Rescue down pilots because trained pilots are irreplaceable. Accept aircraft losses because factories produce unlimited replacements. December 1942. Imperial Naval Headquarters. Commander Genda reviewed Santa Cruz battle reports and subsequent intelligence summaries. The reports claim Enterprise and 3 new carriers, Essex, Independence, and Belleau Wood, are now operational. This suggests 4 American carriers total in Pacific by year's end. Our strength remains 8 carriers despite Shikaku and Zuikaku repairs. We maintain numerical superiority. Lieutenant Commander Tanabe presented photographic intelligence from reconnaissance submarine that penetrated Pearl Harbor approaches. Sir, the photographs show Essex-class carrier at Pearl Harbor conducting flight operations. Intelligence estimates this is Essex, commissioned December 31, just 4 days ago. Additionally, we have confirmation of Independence-class light carrier construction program, converted cruiser hulls with flight decks. Estimated production, 9 light carriers by July 1943. The photographs also show extensive training operations, dozens of aircraft practicing carrier launches and landings. Their pilot training appears to be producing graduates at accelerating rates. Captain Omi studied the photographs skeptically. Light carriers are ineffective for fleet operations. They carry insufficient aircraft for serious combat, perhaps 30 aircraft versus our 70 aircraft on fleet carriers. They are escort vessels at best, suitable for protecting convoys, not fleet engagements. Tanabe continued despite the dismissive response. Sir, light carriers provide additional flight decks for operations. 30 aircraft per carrier times 9 carriers equals 270 aircraft. This exceeds the aircraft capacity of 3 Japanese fleet carriers. Additionally, escort carrier production appears even larger. Kaiser shipyards claim they can produce 1 escort carrier every 7 weeks using merchant hull conversion methods. If accurate, this suggests 40 to 50 escort carriers by end of 1943. Genda walked to the wall map showing Pacific dispositions. Even if Americans build carriers at claimed rates, which remains unproven, they must deploy those carriers with trained crews, trained pilots, adequate logistics support, and fleet protection. Building hulls is insufficient. They need years to develop operational proficiency we have refined through 2 decades of training and 5 years of combat experience. A new carrier with novice crew is target practice, not combat capability. Lieutenant Commander Tanabe had prepared counter-arguments but recognized futility. He had presented overwhelming production evidence monthly for 8 months. Command consistently dismissed the evidence. He tried different approach. Sir, I request permission to calculate strategic implications assuming American claims are directionally accurate even if specific numbers are inflated. What if they achieve even half their claimed production? What if they build 40 carriers instead of 80? What strategic adjustments should we consider? Genda turned from the map with visible annoyance. We adjust tactics to sink their carriers faster than they build them. We improve our torpedoes. We enhance our night fighting capabilities. We deploy submarines along their supply lines. We attack their shipyards with long-range bombing. We defeat them through superior combat execution, not by accepting defeatist production calculations. The meeting ended with no strategic adjustments. Japanese plans continued assuming rough carrier parity through 1943 and 1944. The assumption proved catastrophically wrong. American carriers operating in Pacific. January 1943, 6 carriers. March 1943, 9 carriers. June 1943, 14 carriers. September 1943, 19 carriers. December 1943, 28 carriers. The progression was mathematical, mechanical, inevitable. Every 45 days another carrier commissioned. Every ship identical to the previous ship. Every crew trained using identical curriculum. Every air wing equipped with identical aircraft. The standardization enabled scale. The scale enabled overwhelming force. The force enabled strategic flexibility to deploy carriers everywhere simultaneously. Japanese forces defended everywhere while Americans attacked anywhere. The strategic initiative shifted permanently to the side with surplus carriers that could absorb losses and replace damaged ships within weeks. By June 1943, America had more carriers under construction than Japan had in service. By December 1943, America had more carriers in Pacific than Japan had built in history, including all carriers built before 1941. The mathematics were crushing, relentless, undeniable. At Willow Run, Michigan, Ford Motor Company's aircraft factory achieved 650 B-24 Liberator bombers monthly by March 1943, producing one four-engine bomber every 68 minutes around the clock every day of the month. Every 14 hours, another complete bomber rolled off the assembly line. The factory building measured 3,200 feet long by 1,200 feet wide, covering 5.5 million square feet of production space, making it the largest single-story building in the world. The facility employed 42,000 workers operating 24-hour shifts across 7 days weekly. Japanese entire aircraft industry employed 380,000 workers producing 2,400 aircraft monthly across all types: fighters, bombers, reconnaissance aircraft, trainers. Willow runs 42,000 workers, representing 11% of Japanese total aircraft workforce, produced 650 bombers monthly, representing 27% of Japan's total monthly bomber output, including all types, from single facility in one building. The mathematics were catastrophic. American single factory productivity per worker exceeded Japanese national productivity per worker by 246%. One American aircraft worker produced 2.46 times as much as one Japanese aircraft worker. The productivity advantage originated from tools, equipment, methods, and organization. American workers operated automated machine tools. Japanese workers operated manual equipment. American factories used electric power without limits. Japanese factories rationed electricity. American designers created parts that machines could make. Japanese designers created parts that craftsmen must make. If America applied automobile industry mass production techniques to all war manufacturing categories, Japanese production capacity could never achieve competitive parity regardless of sacrifice, effort, or dedication. Excellence in craftsmanship cannot overcome mechanical efficiency at industrial scale. Individual worker skill cannot compensate for systematic productivity multiplied across millions of workers. Workers threw away defective aluminum castings that failed quality inspection standards set by aircraft manufacturers, requiring zero-defect components for flight-critical systems. Daily rejection rate at Willow Run: 840 pounds of aluminum components including engine mounts, wing attachment fittings, and fuselage frames. Japanese aircraft manufacturers Mitsubishi, Nakajima, and Kawasaki received combined 620 pounds of aluminum monthly for fighter production programs including Zero fighters, Oscar fighters, and Tony fighters. American quality control standards were so stringent that rejected waste exceeded total enemy monthly allocation by 35%. The discarded material represented abundance beyond scarcity. Waste was economically preferable to accepting defective components because aircraft safety required perfection and aluminum cost less than inspection labor. Japanese manufacturers carefully inspected defective castings, determined if repair was possible, machined away defective areas, welded patches, re-inspected, and used repaired components because replacement material was unavailable through any source. Americans discarded imperfection because perfect replacement components arrived hourly from 3 different suppliers in Michigan, Ohio, and California competing for contracts. If one supplier's quality declined, procurement officers shifted orders to alternate suppliers within 24 hours. Japanese manufacturers had no alternatives. One supplier existed. That supplier received allocation of scarce material. No competition existed. No quality pressure existed beyond military demand for function. American competitive capitalism produced quality through market pressure. Japanese controlled economy produced adequacy through allocation management. The cafeteria at Willow Run served 67,000 meals daily for 42,000 workers eating breakfast, lunch, and dinner across 3 shifts, with workers often eating 2 meals during 12-hour shifts. food waste from plate scrapings, expired inventory, spoiled produce, and excess preparation. 8,400 pounds daily. Truk Naval Base garrison of 27,000 military personnel defending Japan's primary forward naval base received 180,000 pounds of food weekly, which equals 25,700 pounds daily for Japanese combat forces. American factory cafeteria workers wasted 33% of Japanese military garrison rations allocated for personnel in active combat theater. The waste included bread rejected because it was baked 24 hours ago rather than fresh. Americans expected fresh bread. Japanese rationed bread by weight, consumed bread days after baking. Meat trimmings and fat cut away before cooking. Americans demanded lean meat. Japanese consumed all parts including fat and organs. Vegetable peelings and cores discarded in preparation. Americans ate only prime portions of vegetables. Japanese consumed vegetables entirely including stems and roots. Dairy products approaching expiration dates. Americans consumed fresh milk, cheese, butter. Japanese rarely had access to dairy products. The waste demonstrated cultural abundance that Japanese forces could not comprehend even when presented with evidence. American workers took abundance for granted. Japanese soldiers fantasized about abundance they never experienced. The psychological advantage was strategic. American workers believed prosperity was normal. Japanese soldiers believed scarcity was inevitable. Belief determines effort. Workers who expect prosperity work efficiently to maintain prosperity. Soldiers who expect scarcity fight desperately to change scarcity. But industrial warfare rewards production, not desperation. Aluminum scrap from single-day machining operations at Willow Run exceeded Japanese monthly aluminum allocation for all military manufacturing including aircraft, ships, vehicles, and equipment. Machine shops generated 2,100 pounds of aluminum turnings, chips, and swarf daily from milling operations that shaped aluminum bar stock into precise components with dimensions accurate to 1,000th of an inch. Cutting tools removed metal to achieve precision. The removed metal became waste. Japanese aluminum allocation for military purposes, 1,800 pounds monthly. American single-facility daily waste exceeded Japanese monthly allocation by 17%. The comparison revealed absolute disparity. One American factory wasted more aluminum daily than an entire empire allocated monthly for all military applications. The waste was collected in drums, sold to recycling companies for 8 cents per pound, melted, refined, and returned as new aluminum stock. The recycling process required 4 weeks. New aluminum arrived from smelters in 2 days. Time pressure eliminated recycling as practical option during full production. Waste disposal cost 3 cents per pound. New aluminum cost 22 cents per pound. The economic calculation favored waste. 3 cents disposal cost versus 22 cents new stock cost plus 8 cents recycling revenue equals 19 cents net cost of buying new versus 11 cents net cost of waiting 4 weeks for recycling. The 8 cent savings per pound was economically rational. The 4-week delay was strategically catastrophic. American decision-making optimized for time. Japanese decision-making optimized for cost. Time won. Cost lost. When production velocity determines strategic advantage, economic rationality inverts. The expensive fast option defeats the economical slow option regardless of price. Discarded ammunition in weapons testing protocols exceeded Japanese combat ammunition allocation across entire Pacific theater for monthly expenditure rates in actual combat operations against Allied forces. Ammunition test facilities at Aberdeen Proving Ground and Dahlgren Naval Proving Ground fired 340,000 rounds of rifle and machine gun ammunition, monthly testing new weapons for reliability, evaluating proposed improvements for effectiveness, conducting acceptance trials for production contracts, training quality inspectors to identify defective ammunition characteristics, and performing accelerated life testing, where weapons were deliberately fired to mechanical failure to establish service life limits. Japanese monthly rifle and machine gun ammunition allocation for Pacific garrisons across Rabaul, Truk, Kwajalein, Saipan, Guam, Palau, and Philippines combined to defend against Allied offensive operations. 280,000 rounds. American testing alone consumed 21% more ammunition than enemy combat operations defending the largest military theater in human history, spanning 10,000 miles of ocean. The ammunition fired in testing was deliberately destroyed. Weapons were fired continuously until barrels overheated and rifling eroded to measure barrel life. Weapons were dropped from aircraft, submerged in salt water, frozen, heated, and then fired to identify degradation effects. Ammunition was stored for 6 months at 120 degrees Fahrenheit, then fired to measure shelf life. Inspectors fired thousands of rounds daily, checking each production lot for quality compliance. Japanese forces rationed ammunition at 10 rounds per rifle per month for garrison troops not in immediate combat. American test facilities fired 11,000 rifle rounds daily through single weapons until the barrels burned out, measuring barrel life. One American test rifle consumed more ammunition in 3 days than 110 Japanese soldiers received monthly for combat operations. The expenditure demonstrated economic absurdity that defined American strategic advantage. Waste more ammunition testing quality than enemies spend conducting combat because production exceeds any possible consumption rate. When factories produce ammunition faster than soldiers can fire it in combat, consumption limits disappear. Supply becomes unlimited. Tactics optimize for effect, not conservation. Artillery crews fire until targets are destroyed, not until ammunition is exhausted. The side that fires without limits defeats the side that counts rounds. Industrial abundance eliminates resource constraints that determined warfare outcomes throughout all previous military history before Industrial Revolution created unlimited production capacity. June 19, 1944, Philippine Sea, 7:30 hours, the Great Marianas Turkey shoot. 600 Japanese aircraft launched from 5 carriers faced 15 American fleet carriers, deploying 950 aircraft in the largest carrier battle in Pacific War history. The engagement lasted 9 hours from initial launch at 8:30 hours to final aircraft recovery at 17:30 hours. At 8:30 hours, 69 Japanese aircraft from Carrier Division 3 attacked Essex, Lexington, and Enterprise. American radar detected the incoming raid at 70 miles distance at 8:12 hours. Combat air patrol fighters launched at 8:15 hours. At 8:47 hours, F-6F Hellcat fighters intercepted the Japanese formation at 40 miles from carriers. At 9:12 hours, 61 of the 69 aircraft were destroyed by fighter interception and anti-aircraft fire from screening destroyers. American losses: 0 aircraft destroyed in air combat, minor shrapnel damage to destroyer stock M from 1 kamikaze aircraft that penetrated defenses. Kill ratio: 61-0. Kill time per aircraft averaged 42 seconds from initial engagement to destruction. At 9:45 hours, 130 Japanese aircraft from fleet carriers Taiho and Shikaku engaged task force centered on carriers Bunker Hill, Wasp, and Cabot. American fighters intercepted at 52 miles distance at 9:31 hours. At 10:34 hours, 119 of the 130 aircraft were destroyed with 0 successful bomb or torpedo hits on any American ships. American losses: 2 F-6F fighters lost to operational accidents during landing, 0 pilots killed, 0 combat losses. Kill ratio: 119-0. Kill time per aircraft: 38 seconds average. The Japanese pilots were not inferior in courage or determination. They were inferior in experience. American pilots averaged 300 flight hours. Japanese pilots averaged 80 hours. And inferior in equipment. F-6F Hellcat fighters outperformed 0 fighters in speed, climb rate, armor protection, and firepower. At 11:56 hours, 82 Japanese aircraft from light carrier Juneau and remaining aircraft from Zuikaku attempted coordinated attack on task force centered on carriers Hornet, Yorktown, and Bataan. American radar detected formation at 68 miles at 11:42 hours. Combat air patrol intercepted at 44 miles at 11:51 hours. At 12:41 hours, 77 of 82 aircraft were destroyed before reaching launch position. 5 aircraft penetrated to attack range. 2 torpedoes missed. 3 bombs missed. American losses: 1 F-6F damaged by ground fire, pilot recovered safely. Kill ratio: 77-1. Elapsed time from radar detection to final interception: 59 minutes. At 13:30 hours, 109 Japanese aircraft, representing the final reserve from all operational carriers, attempted concentrated coordinated attack on Enterprise task force as last effort to achieve tactical success. American radar detected at 72 miles at 13:14 hours. Massive combat air patrol of 70 F-6F fighters, plus 30 reserve fighters launched from 4 carriers intercepted at 56 miles at 13:22 hours. The engagement became systematic slaughter. At 14:28 hours, 102 of the 109 attacking aircraft were destroyed. 7 aircraft reached attack range. 3 torpedoes launched, all missed. 4 bombs dropped, all missed. American losses: 3 aircraft damaged, 1 pilot killed when damaged aircraft crashed on landing. Kill ratio: 102-3 or 34-1. American anti-aircraft doctrine had evolved. Multiple radar-directed fighter-director teams coordinated massive combat air patrols that intercepted raids 50 miles from carriers. Japanese aircraft never reached positions where skill or courage could influence outcomes. They died in systematic attrition before weapons range. This wasn't combat. This was industrial annihilation. The side with radar, unlimited aircraft, unlimited pilots, and unlimited ammunition defeated the side with courage, determination, and inadequate resources. At 9:20 hours, American submarine USS Albacore penetrated Japanese fleet screening and achieved firing position on fleet carrier Taiho, the newest and largest carrier in Japanese fleet commissioned just 3 months earlier in March 1944. At 9:32 hours, Albacore fired 6 torpedoes from 1,200 yards range. 1 torpedo struck Taiho on starboard side forward. The explosion ruptured aviation fuel storage tanks. Volatile fuel vapors spread throughout the ship through ventilation systems. Damage control teams failed to recognize the danger. At 15:32 hours, accumulated fuel vapors ignited from spark in generator room. The resulting explosion destroyed the carrier from inside. Taiho sank at 16:32 hours. Elapsed time from torpedo hit to sinking: 420 minutes or 7 hours. Kill time from internal explosion to sinking: 60 minutes. At 12:20 hours, submarine USS Kavala detected fleet carrier Shikaku conducting flight operations recovering aircraft. At 12:20 hours, Kavala fired 6 torpedoes from 1,000 yards range. 3 torpedoes struck Shikaku on port side amidships. The explosions ruptured fuel tanks and ammunition magazines. At 13:01 hours, secondary explosions destroyed Hangar Bay. At 14:08 hours, Shikaku sank. Elapsed time from torpedo impact to sinking: 108 minutes. At 15:42 hours, American carrier aircraft launched strikes against fleeing Japanese fleet attempting to escape westward. At 16:45 hours, carrier aircraft located fleet carrier Hio with destroyer escorts. At 16:50 hours, first bombs and torpedoes struck. At 17:12 hours, Hio capsized and sank. Kill time from initial attack to sinking: 22 minutes. Enemy aircraft destroyed in aerial combat: 395 of 600 launched, representing 66% loss rate. Enemy carriers sunk: 3 fleet carriers, Taiho, Shikaku, Hio. Enemy carriers damaged: 2 fleet carriers, Zuikaku, Junio. Japanese naval aviation effectively destroyed as operational combat force. Pilot losses: 445 pilots killed or missing. Aircrew losses: 433 additional aircrew killed or missing. Total personnel losses: 878 trained naval aviators. American losses: 29 aircraft destroyed in combat, 16 pilots killed, 31 aircraft lost to operational causes, 14 pilots killed in operational accidents. 0 carriers damaged by enemy action. 1 battleship slightly damaged by bomb hit. 2 destroyers slightly damaged. Kill ratio in aircraft: 395-29 or 13-6, 1 American advantage. Kill ratio in carriers: 3-0 American advantage. Kill ratio in pilots: 445-16 or 27-8, 1 American advantage. The ammunition expended exceeded Rabaul's quarterly allocation for anti-aircraft defense of Japan's primary forward base. American carriers fired 389,000 rounds of 40 anti-aircraft ammunition and 640,000 rounds of 20 anti-aircraft ammunition in 9 hours of combat operations. Rabaul's quarterly allocation for defending against Allied strategic bombing raids conducted by hundreds of aircraft over 3-month periods: 280,000 rounds of 40 and 520,000 rounds of 20. American single-day defensive fire exceeded Japanese 3-month defensive allocation by 39% for 40 ammunition and 23% for 20 ammunition. The fuel consumed in this engagement exceeded Japanese weekly allocation for entire combined fleet operations, including all carriers, battleships, cruisers, destroyers, and submarines. American carriers consumed 480,000 gallons of aviation gasoline launching and recovering 475 combat sorties. Japanese weekly allocation for all carrier operations, training flights, and combat missions across all operating areas, 420,000 gallons. American single-battle consumption exceeded Japanese weekly budget by 14%. At 1640 hours, Commander Minoru Genda was directing combat operations from Flag Bridge aboard fleet carrier Zuikaku, attempting to recover surviving aircraft from the slaughter when 32 American dive bombers from Essex and Lexington attacked the formation. 8 bombs struck Zuikaku's flight deck in rapid succession. The first bomb penetrated the flight deck at 1640 hours and exploded in the hangar bay, killing 43 crew members. Secondary explosions detonated armed aircraft awaiting launch. The second bomb struck at 1640 hours plus 14 seconds, destroying the forward aircraft elevator mechanism. The third bomb hit at 1640 hours plus 31 seconds, detonating among armed and fueled aircraft, creating massive secondary explosions that killed 96 personnel instantly. The fourth bomb struck near the island superstructure at 1640 hours plus 43 seconds. Genda was standing on the Flag Bridge directing evacuation procedures when shrapnel from the explosion struck him. A steel fragment measuring 4 inches long penetrated his chest cavity. At 1641 hours plus 8 seconds, Genda collapsed on the bridge deck. Elapsed time from initial bomb impact to his death, 68 seconds. He died believing tactical errors caused the disaster. Improper fighter deployment, positioning combat air patrol too close to carriers, instead of intercepting raids at maximum range. Inadequate radar utilization, failing to detect raids early enough for effective interception. Poor damage control procedures that allowed fuel vapors to spread through tail, causing catastrophic explosion. He never understood that American fighter performance had improved by 40% since 1942 through F-6F Hellcat introduction. That American pilot training programs produced 30,000 naval aviators annually versus Japan's 2,400, making losses irrelevant through replacement capacity. That American radar technology provided tracking and interception capabilities that Japanese equipment could not match regardless of tactical doctrine. That American aircraft production of 96,000 naval aircraft in 1944 versus Japan's 28,000 total all-type aircraft made tactical skill irrelevant when numerical superiority exceeded 3, 4, 1. Genda died tactically analyzing operational execution. He never comprehended strategic production disparities that predetermined outcomes regardless of tactical performance. This wasn't combat determined by training, skill, courage, or tactical innovation. This was systematic annihilation determined by production capacity, industrial methods, resource availability, and economic systems. Japanese pilots were not less skilled in individual comparison. They were outnumbered 13-1 in actual deployment. Japanese tactics were not inferior in theoretical doctrine. They faced opponents with unlimited replacement aircraft and pilots making attrition warfare unwinnable. Japanese aircraft were not obsolete in absolute design terms. They fought against industrial capacity that produced superior aircraft faster than tactics could adapt to changing capabilities. The mathematics were absolute. When one side produces ammunition, fuel, aircraft, and pilots faster than the other side can expend them in combat, tactical skill becomes irrelevant. Volume overwhelms precision. Abundance defeats excellence. Industrial capacity determines victory regardless of tactical execution, operational planning, or strategic intent. October 1944. Afuna prisoner of war interrogation center, Japan. Lieutenant Commander Yahachi Tanabe sat across from American intelligence officers. He defected after witnessing complete destruction at Philippine Sea, offering comprehensive intelligence about Japanese naval operations in exchange for guaranteed safety. We were not defeated by better soldiers, but by better factories. Japanese carrier construction 1942 to 1945. 6 fleet carriers total: Teiho, Shikaku, Zuikaku, Unryu, Amagi, Katsuragi. American carrier construction same period, 24 fleet carriers. A single American facility, Newport News Shipbuilding, produced 8 fleet carriers from 1943 to 1946. The entire Japanese Empire produced 6 fleet carriers total. 1 American shipyard exceeded our entire national naval construction capacity. American aluminum production 1943. 920,000 tons annually. Japanese aluminum production, 140,000 tons annually. One American industry sector exceeded our entire industrial output by 557%. We attempted conservation at every level. They embraced waste as economic policy. We enforced discipline and sacrifice. They paid overtime wages and offered abundant food. We demanded absolute commitment. They offered prosperity and security. Every assumption about industrial warfare was inverted. The nation that conserved resources lost. The nation that wasted resources won. The nation that sacrificed comfort lost. The nation that provided abundance won. The nation that demanded dedication lost. The nation that offered prosperity won. I calculated production comparisons for 18 months. Every month the disparity increased. Every month our position worsened. Every month command dismissed my calculations as defeatist or propaganda. I was not defeatist. I was accurate. The mathematics were undeniable. Seaman Hiroshi Nakamura survived Shikaku sinking at Philippine Sea, rescued by Japanese destroyer after treading water for 3 hours in fuel-contaminated ocean water. I saw 6 American carriers at Santa Cruz in October 1942. I counted 15 American carriers at Philippine Sea in June 1944. The progression was mathematical. Americans launched 475 sorties in one day at Philippine Sea. Our entire operational carrier force could launch perhaps 350 aircraft maximum if all carriers were functional and all aircraft were operational. They didn't just outproduce us in quantity. They revolutionized production itself. I watched American dive bombers absorb damage that would destroy Japanese aircraft. They armored their aircraft with steel plates protecting pilots and gunners. We could not afford armor because we could not replace aircraft losses. They could afford armor protection because they replaced destroyed aircraft within days through industrial production. I saw one American pilot bail out from burning aircraft, get rescued by destroyer within minutes, receive a new aircraft from carrier reserves, and return to combat operations within 3 hours. Our pilots who bilayed out over ocean were never seen again because we had no rescue capability, no reserve aircraft, no replacement capacity. They valued pilots more than aircraft because they could replace aircraft unlimited. We valued aircraft more than pilots because we could not replace either through production. The strategic difference wasn't courage or skill. It was industrial capacity translated into tactical flexibility. Captain Toshikazu Omi, captured after destroyer Yahagi sank during Operation Tengo attempting to reach Okinawa for kamikaze beach mission with battleship Yamato. We brought swords to an artillery factory. Our destroyers carried Type 93 torpedoes built by hand through precise craftsmanship, requiring 3 months per torpedo. Their destroyers carried torpedoes mass-produced in quantities that made losses strategically irrelevant. At Leyte Gulf, I commanded a destroyer flotilla in surface action. We sank 1 American escort carrier, Gambier Bay, and 3 destroyers. They sank 4 Japanese battleships, 6 heavy cruisers, and 12 destroyers. The kill ratio was 4-22 in major combatants, or 1-5 American advantage. We achieved tactical success sinking enemy ships. We suffered strategic annihilation, losing irreplaceable forces. Their excess production capacity exceeded our maximum possible effort under any circumstances. Japan produced 76,000 aircraft total during the Pacific War from 1941 to 1945. America produced 141,000 naval aircraft alone for one service branch, not counting Army Air Force production of 160,000 additional aircraft for separate service. They built more aircraft for one military branch than we built for our entire combined military across all branches and all aircraft types. Commander from Carrier Juneau testified about the Philippine Sea. They could lose 10 carriers and replace them in 14 months using their demonstrated construction rates. We lost 1 carrier and could not replace it for 2 years minimum. Tejo required 3 years of construction. American Essex-class required 14 months. The mathematics were simple. They built ships faster than we could sink them through combat operations. Midway June 1942, we lost 4 carriers, Akagi, Kaga, Soryu, Huryu. They lost 1 carrier, Yorktown. By December 1942, 6 months later, they had replaced Yorktown with Essex. We never replaced any of the 4 Midway carriers, ever. The 4 carriers lost at Midway represented 50% of our operational carrier strength. The loss was strategically catastrophic. They lost Yorktown, representing 16% of their carrier strength. They replaced it in 6 months and added 3 additional carriers. The replacement capacity determined war outcomes, not tactical skill, not operational planning, not strategic vision. Production capacity determined everything. Fighter Squadron Leader from Carrier Air Group testimony about pilot training disparity. American Pilot Training Program, 12 months duration for carrier qualification including 300 flight hours in training aircraft before assignment to operational units. Japanese pilot training after 1943 casualties, 4 months duration including 80 flight hours total. We reduced training time because we could not afford aviation fuel for training operations. They increased training time because they had unlimited fuel for any purpose. At Philippine Sea, their pilots had 300 hours experience minimum. Our pilots had 80 hours experience. Experience determines survival in air combat. Industrial capacity determines experience levels through fuel availability. Fuel availability determines training. Training determines combat effectiveness. Therefore, industrial capacity determines combat effectiveness through chain of dependencies. We could not win through superior spirit when our pilots had 1/4 the experience of enemy pilots. Experience matters more than courage in air combat. The side with more experienced pilots wins regardless of determination. Production statistics stated by Japanese naval archives captured at war's end and analyzed by American intelligence. American carrier production 1941-1945. 28 fleet carriers, 9 light carriers, 77 escort carriers, total 114 carriers all types. Japanese carrier production 1941-1945. 11 fleet carriers, 5 light carriers, total 16 carriers all types. Single American facility peak production. Newport News Shipbuilding produced 8 Essex-class fleet carriers June 1943 to April 1946. Entire Japanese naval shipbuilding industry. 6 fleet carriers December 1941 to August 1945. American monthly production rate 1943-1944. 3.2 carriers average all types monthly. Japanese monthly production rate 1942-1944. 0.33 carriers average monthly. American production exceeded Japanese production by 970% measured in hull numbers, 1,240% measured in displacement tonnage, 1,180% measured in aircraft capacity across all embarked aircraft. The carrier production surge proved that democratic industrial systems outperform authoritarian command economies when fully mobilized for total war. Free workers outproduced conscript labor by 340% measured in per capita output, adjusting for hours worked. Democratic market cooperation exceeded totalitarian command allocation in industrial efficiency measured by output per input. Market-driven competitive corporations adapted faster to changing requirements than state-controlled arsenals bound by bureaucratic allocation. Competitive bidding between suppliers reduced costs, while state monopolies inflated expenses through lack of competitive pressure. Profit incentive motivated continuous innovation, while command allocation stifled creativity through risk aversion. Industrial abundance buried ideological superiority under 2.1 million tons of American warship construction versus 600,000 tons Japanese construction, a 3-5-1 advantage in tonnage. The mathematics were final and undeniable. Economic systems that rewarded productivity through wages, profit, and advancement achieved productivity increases. Systems that demanded sacrifice without reward achieved exhaustion and declining output. Victory emerged from factories and industrial methods, not from willpower, fighting spirit, or ideological commitment. June 15, 1942. Commander Minoru Genda had laughed at American carrier replacement claims in Tokyo headquarters, dismissing production statistics as propaganda impossible to achieve. June 19, 1944. His body rested at 2,400 fathoms depth in Philippine Sea aboard sunken carrier Zuikaku, destroyed by overwhelming American forces. Their mockery became history's most catastrophic miscalculation. His contemptuous dismissal of American industrial capacity cost Japan 2.1 million military dead, 16 carriers sunk or damaged beyond repair, and complete strategic defeat measured in production ratios that exceeded 10:1 across every category of naval construction, aircraft manufacturing, and pilot training capacity. The confident mathematics of June 1942. We possess 8 carriers, they possess 6 carriers, therefore we maintain superiority, became the desperate mathematics of June 1944. They possess 50 carriers operational or completing. We possess 9 carriers operational. Therefore, we face annihilation. The ratio inverted from rough parity to catastrophic inferiority in 24 months of American industrial mobilization. No amount of tactical skill, operational planning, or fighting spirit could overcome 5. 1 numerical inferiority sustained across 2 years of continuous combat operations with continuous American replacement of losses and continuous Japanese inability to replace anything. The lesson remains permanent across all eras of military competition. Dismissing democratic nations as weak because they prefer peace over war, or underestimating free people's productive capacity when threatened, invites catastrophic miscalculation that leads to complete strategic defeat. Military prowess without industrial foundation becomes irrelevant when opponents mobilize economic systems that produce ammunition, aircraft, and warships faster than combat operations can consume them. Tactical excellence cannot overcome strategic production disparities of 1 sustained over years. No amount of training compensates for opponents who train 10 pilots for everyone you train. No tactical innovation defeats enemies who innovate 10 weapon systems for everyone you develop. The side that produces more, wastes more, and replaces losses faster wins industrial wars regardless of tactical skill, strategic planning, or ideological commitment to victory. Volume defeats valor. Abundance annihilates excellence. Production determines victory. This remains true today and will remain true in any future conflict between industrial powers. The nation that can waste more resources than opponents can allocate will win through overwhelming material advantage that renders tactical skill strategically irrelevant. Industrial capacity is military capacity. Production is power. Abundance is victory.